I'm Andrew Brunson, and I'm going to talk a little bit about a model of theoretical physics for affine transformations. Um, First of all, theoretical physics is math models and abstractions. You're not really doing the experiment yourself, you're just telling people like the process of. Uh, some rules are everything is a product of nature, smaller things are more adaptable and complex, and all nature is distorted, like trees bending, coming out in random directions. Even nuclear fusion has diffusing hydrodynamics of like fluidity spinning everywhere. So to make it natural, distort it. This process is called affine transformations. The key is contraction. Make it squeeze so it's solid in structure. Think of ratios, not actual results. Like don't water the sand every day and don't put like the same thing around it every day. Just like make it random to a degree, so it like twists and bends and contracts and squeezes, so it's solid. Uh, Featured lines would include seeds like replicating tomato plants. An example properties are maintained. Wait, Fractured lines, which would include seeds like a replicating tomato plant, is an example of where properties are maintained, like a plant that grows back. The elements used in this are like linear algebra, vectors, and matrices. It starts in a column, but you can transpose it, which is like if it's right here, you flip it so it's linear, so it's like x, x2, x3, so on. This sets up a geometric space. It's called Euclidean geometry, and the x is the width or length, the y is the width or length, and the z is height. You can name them whatever you want, I guess. You set up an augmented matrix. An example, f is linear transformations, m is linear transformations, or it's x plus y. Euclidean geometry moves out every part in a given direction equally. So you expect the space to be taken up, but in shear mapping it displaces linearly every point in a fixed direction. That's where the distortion comes in, the coordinates for x, y, and z. To know supports and how much support a part of the structure can give, use trigonometry. It's called translation of axes, and you find the fixed points and make new vectors. So x would be like x minus h, or x minus k, or whatever you want to call it, and then y would equal y minus k, and you rotate the structure to make a 2D view of it, but it could still be a 3D structure. But you can use these for growing plants or photos, like Photoshop, whatever, if you want to get a new point of view. There could be a complex structure to primary and look at the supports with the new matrix. Uh, Find average expected, or known sizes of plants or photo object of importance. You can, with geometry and ratios, make a new matrix of predicted growth, a way to set up photos. So basically you just make things not random, but you like equally distort them multiple times, and it should look natural instead of the other way. Thank you, bye.